All right, so 9.6 exponential functions is a function that can be described by an equation of the form y equals ab to the power of x, where a can't be 0 because then that'd just be 0, and b has to be greater than 0 and cannot be equal to 1. So examples would be y equals 2 times 3 to the power of x, or 4 to the power of x, or a fraction to the power of x. So graphing them, we have y is equal to x to the, or excuse me, 3 to the x power. So if x is a negative 2, that means it'll be 3 to the negative 2, and something to the negative 2 power, remember it's the reciprocal, or it's 1 over 3 to the second power, which is 1 over 9. So 3 to the negative 2 power is 1 over 9. And then we do the same thing with negative 1, which will be 1/3. Any number to the 0 power is 1, and then 3 to the first is 3, and 3 to the second is 9. And then when we graph them, we get this. So that is the graph of y equals 3 to the second power. Number 2, notice I have more input values because this 2 is smaller. So when we do 1/2 to the negative 3, we do the reciprocal and it's positive 3, and 2 to the third power is 8. So negative 3, 8. And then you can continue doing the inputs, and we get 4, we get 2, 1, 1/2, 1/4, and 1/8, 2, 4, 8. And then the graph of the values are over here. Okay, so here's a word problem. How do we apply this? How do we use it? So here it is. Bacteria can double every 20 minutes. Beginning with 10 cells, the population can be represented by the function y equals 10, that's the 10 cells, 2, the doubling, and then x. Well, how many times is it going to double? How many will there be after 2 hours? Well, remember it doubles every 20 minutes. There are 3 20 minutes in an hour, or 6 total in 2 hours. That means it's going to double 6 times. So that means x is going to be 6. So y equals 10 times 2 to the power. So 10 times 2 to the power of 6. Remember, you do exponent first. 2 to the 6th power is 64. And then 64 times 10 is 640. So 2, 4, 8, 16, 32, 64. Just double checking my math. So we get 640 cells. So that's how you do number 3. All right, number 4. Here's one where instead of it increasing, we have a depreciation. In other words, the vehicle, when you drive it off the lot, it starts decreasing in value. So this is a representation of a 20% decrease. So let's take a look. A car or truck depreciates in value over time. So this function models the depreciation of a $25,000 car or truck. What is the car expected value after 5 years? Okay, well, that means we're going to put a 5 in for our x, in for the x right there. So we get 25,000 times 0.8 to the 5th. Well, 0.8 to the 5th, you would multiply that out 5 times, and you get 0.32768 times 25,000 will give you 8,192. So a vehicle, if it depreciates in this rate, would have a value of $8,192, which would be pretty close to real life valuation. Number 5, we want to graph this. So on number 5, y to the 4, y is equal to 4 to the x power. Again, negative 2, negative 1, 0, 1, 2. When you put negative 2 in here, remember that's going to flip it. So it'll be 1 over 4 squared, which is 1/16. Do the same thing with -1. It'll end up being 1/4. 0, anything to the 0 power is 1. And then 4 to the first is 4, and 4 to the second is 16. And your graph over here, where I don't have the 16 value up here. Okay, so that's how you graph it. Number 6. So here we have, again, a fraction to the -2 power. Do the reciprocal, 16. -1, reciprocal 4, to the 0, anything to the 0 power is 1. Put 1 in there, you get 1/4. Put 2 in there, you get 1/16, and there's your graph. It's just like the one above, number 5, except going the other way. Okay? And then number 7, what would the value of a car after 10 years? For problem number 4, so up here, instead of doing this equation to the 5th like I did in this problem, we're going to do it to the 10th. Okay, so down here, when we do it to the 10th, this number to the 10th power is this. Multiply, and I get this. So the value of the truck will roughly be $2,684.35. All right, you do not have an assignment on this lesson. Just make sure that you know how to graph from a function, and 4 and 7. Make sure you know how to do problems like that, but there is no assignment. All right, have a good day and good luck.